Good morning, everyone, or afternoon, wherever you may be. Thank you for joining us today. My name is Andy Deal with SarahTech, and I'll be your host. So today we have a special guest from BigRep, Mr. Frank Marangell from BigRep. He will be sharing with us some insights into how companies in various industry are using 3D printing to change the game today. And Frank will also highlight a few case studies of customers who uses 3D printing to speed up development and cut production costs. So there's a lot of cool information to share with you today. Just a quick glance at our agenda. I do want to remind you that we have a Q&A session at the end of the webcast. So at any time, if you have questions, please enter them into the Q&A panel of your GoToWebinar Control Center, and we will address them at the end. Before that, hang on one second. I'm getting a little bit of a feedback. All right, hopefully you can hear me okay. Before that, I want to take a couple minutes just to talk about Saratech and what we do. So as an engineering organization, Saratech has been helping customers optimize design, analysis, and manufacturing processes since 2002. With over 90 dedicated professionals, and over half of which are engineers, we earn the trust of customers by delivering results and building great relationships. We also partner with industry leaders like Siemens PLM, HP, and BigRep to bring you the latest design and manufacturing technology available in the market today. We're headquartered in Orange County, but our team is located throughout the United States to best support customers across the country. So at this time, I'd like to introduce Mr. Frank Marangell, the President of BigRep America and CBO of BigRep Germany. Frank, I'm passing the presentation over to you.
Thanks, Andy, and my pleasure to be here today and welcome everybody to this presentation from BigRep on how large format 3D printing is transforming industries. We have some very interesting applications we want to talk about. Next, please. Yes, so on the BigRep agenda, we're going to explore the 4 main applications for large format 3D printing and a few customer use cases for each of those applications and the benefits those customers get out of those use cases. And it's really exciting to see how our customers are using large format 3D printing, the BigRep 3D printers. And then at the end, it's not a sales pitch, but I have a couple slides just for anybody that doesn't know BigRep about some of our most exciting recent technology. So the first thing that is really interesting and what keeps me excited about this industry is that 3D printing is all around us, that you can't touch something today that wasn't affected by 3D printing, whether it be the design or the manufacturing of it, or from a safety standpoint, 3D printing is getting into medical and dental. So 3D printing is all around us, and it's a really exciting industry. It's 30 years old, but it really feels like it's just beginning. And some of the applications we'll talk about today really emphasize how it's still growing strong and it's still in its early stages of development. It's very exciting. Next. I put this slide in just to show that the industry, although 30 years old, has grown, has doubled over the last 5 years from 2014 to 2019, and is expected to double again by the time 2025 comes along. So it's really interesting. Now, if manufacturing takes off in additive, these numbers will even be blown out of the roof. So the 3D printing industry is some version of $8 and $12 billion total, and manufacturing is something in the tens of trillions of dollars. So it's really an exponential factor from one to the other. So if 3D printing can take a piece of that, it's very exciting. I did use this particular chart. Sorry, Andy, one more second there. I did use this particular chart because BigRep is in the fused deposition modeling. It's not our slide. I would typically use thermoplastic extrusion as more of a generic term for the FDM technology. But as you see this fused deposition modeling slide, that area is growing faster than anywhere else. And BigRep in the large format version of the thermoplastic extrusion is even growing faster than the general market. So we're very excited about where this piece of the industry is going, where the industry is going, and of course where BigRep is going. No, thank you. All right, so one of the questions I get all the time from people that want to get into to 3D printing is where do I start? What do I print first? And hopefully this presentation can give you some ideas. If you're in mechanical design, then this would be a good, we have some applications in that regard. Manufacturing tooling, in end-use parts, if you want to really be bold, in patterns and molds. So we have many applications here, and hopefully this presentation can help you think about different places where 3D printing might fit in your facilities. Next. So the four main applications for large format thermoplastic 3D printing is prototyping, and prototyping is 60% of this market. Tooling, manufacturing tooling, that is, and that is about another 20%. So 80% of the large format 3D printing today is in prototyping and manufacturing tooling. One of the most exciting growth areas right now is in patterns, molds, and castings, and we have an application on that here, talking about that marketplace and that application. It's really interesting, and as I mentioned earlier, the really holy grail of this industry and where it's going to grow exponentially is in the application of end-use parts. Today, it's a very small percentage of the total market, but has the potential to be a traditional accepted manufacturing process as molding, milling, casting, forming, and additive manufacturing. And you see some applications that it's really starting to take off right now, and we have a couple examples of that here. So let's get started. Yeah, the first application is prototyping. Next. So the first thing that you have to think about when you want to do prototyping is what do I want to prototype? What's the size of the part that I want to prototype? So that's the first calculation to help you decide what machine you might want to use. Then from there, you have to determine, do I want to do concept modeling or do I want to do functional modeling? And each one of those characteristics will lead you down a different path, either a different path of systems because of different specifications, or a different path of materials and material properties because of what you want to do with your prototype. So let's look at those three criteria next. So the first one was size, and size is important in 3D printing, and that's why large scale is really growing, because previously to companies like BigRep, there wasn't an ability to print with a very large scale. So everybody that wanted to make an additive prototype printed it in pieces, and that meant that they needed to take the CAD data, they needed to slice it up and print it in pieces, then they needed to glue it together, and that caused a great increase in time, but also a reduction of geometric accuracy and physical strength. So with the ability to print the entire piece in one print, you're actually able to retain your geometric accuracy, really make an easier print. So you just load it onto the print bed and then you push print, and you're also to get full mechanical properties out of the printer. So this particular printer, the orange bed up above, is the top view of the BigRep 1. It's one of the first, and it is the largest volume of serial production for large-scale 3D printing. There is somewhere near 400 printers in the marketplace of the BigRep 1. Its first generation came out in 2014. We're on the third generation, and then the third version of the third generation of the BigRep 1. So it really is our flagship. The particular bed size that we're looking at is 1 meter square, and it's 1 meter in the Z. So it's a print area of 1 meter cubed, and very few things need to be printed that are larger than 1 meter cubed. We do get those, but very rarely. Most times customers are very happy with the 1 meter cube being big enough for everything they want to print. Next. So then, like I mentioned earlier, you want to decide, do you want to do concept modeling? Do you want to do functional modeling? Both of those give the benefit of accelerating the product development process. So what does that mean? That means either you can get to market faster, as the last bullet tells you, or you can produce and test more iterations. So, or you can do both, and most companies do both. So you're able to iterate much faster when you have a prototype that comes off and you can test it and you can say, oh, I want to change this or this is not what I expected. And you also can get to market faster. If you had to go outside or you had to go with traditional technology, you're not able to do that. And then your both processes reduce costs compared to the more traditional technologies. So that's prototyping with additive manufacturing in general. Now, if you're doing just concept modeling, you're really just worried about form and fit. So the particular material properties are not important. You care about geometric accuracy, you care about surface finish, forms and fit, but you don't really want to use it in a functional way, so you don't worry about the mechanical properties. Then a functional prototype will do and need everything that's in the concept modeling, but also wants to be used in a functional way, like the end use part will be used. So you then need to put a little more attention onto the particular material you're using. What is the function that you're doing? It might be tensile strength, it might be tensile modulus, flex strength, flex modulus, it might be heat deflection temperature, and you need to look at each one of those characteristics to see, is my functional prototype going to represent the functional end use part that I'm trying to demonstrate? And so puts a little more challenge into your decision making before you choose what machine, what company, and what material you want to use. Next. So my first case study is actually an internal BigRep prototype. This was an idea from our Chief Innovation Officer, Daniel Buning. And Daniel said, let's make a fully electronic motorcycle. So he had a dream, and the gentleman here in the picture is Marco Mattia Cristofori, is one of our creative engineers. He took that challenge from Daniel and said, yeah, let's see if we can do it. This fully mirror electric motorcycle, maybe you saw it at a local trade show. We had it at the Rapid show in May. And this entire motorcycle went from ideation to creation in 12 weeks, as you see here. It is 15 3D printed parts. They went through multiple iterations during that 12-week process. So you can imagine trying to create a fully functional motorcycle that has the rims and the suspension and the tires and the steering and the seat, all 3D printed. The lens for that front light that you see there in the picture, all 3D printed, and a fully functional bike. So here, this is actually Marco riding his baby through the streets of Berlin. The only thing that is not 3D printed is the battery, the lights, and some of the cables. So it's just an idea to show you, if we can do this, you can do anything with prototyping 3D printing. Next. So the next case study, perhaps a little more industrial, but a little less exciting, is Steelcase. Probably everybody heard about Steelcase. They are the largest industrial furniture company in the world. They used to make prototypes the old-fashioned way. They used to carve them out of foam and wood. A few years ago, they progressed to smaller 3D printers, and that didn't satisfy their needs either. When they were using smaller 3D printing, they had to piece the pieces together. They weren't getting good representation of either the geometric accuracy or the strength. And really, when you're making furniture, you need to have all of those characteristics on hand in the prototype. So what was happening is they were having to change their end casting molds more than they would like. They bought a BigRep one, a large format 3D printer, and they're really excited to be able to make a fully functional strength and geometric accuracy part that allows them to go from prototype to tooling without fail, and they're really excited about that. A big savings in costs and great time savings, and getting to market with a better product. And again, when you're the leader, when you're the best, you want to make sure you get to market properly. They actually had such a success from their original one. They put a BigRep one in all their manufacturing sites around the world. Next. And here's a quote that I put into the presentation from Michael Hell, the director of design. And I really can't say it better than Michael did. And I think it's indicative of 3D printing in general. So let me read it. It says, one of the things that really amazing about BigRep is that you can create full-scale models. It's important because you don't really understand what a piece of furniture means in the real world until you have it in full size. And I think that's true in so many industries. And that's why, as I mentioned, BigRep is growing faster than the marketplace. So thank you for that quote, Michael, and thank you for your customer references. So that's prototyping. The next application for large format 3D printing is tooling, or as I say, manufacturing tooling. So let's look at a few case studies here. Next. So tooling in general is something that, as I mentioned, is 20% of the thermoplastic extrusion marketplace. And it's one of the most exciting places in the market applications, because customers are coming up with new and exciting tools every day on what to do with it. I'd say when a customer buys a system for one application, it is quickly overcome by many applications. And that's why we have many customers that buy one machine and within a year or two need to buy a second and a third machine, mostly for this application, for tooling. Tooling allows you to create your production line before you actually have a sample prototype. And that used to be a big problem in the marketplace, that you needed to have a prototype before you could start to make your tools. So you couldn't actually test your manufacturing line as you were creating your prototypes. So now, because you can use CAD data to create your tools and 3D printing to create your jigs and your fixtures and your custom trays, you're actually able to test out your manufacturing line in the prototype process, not in the main production. On top of that, Additive gives you the ability to make a lighter weight tool, so ergonomically it's better. And it allows you to make a higher quality product because of the customization. So in areas where you might have had defects before, you can create a manufacturing tool that better aids the manufacturing process to create less defects. Definitely a safety factor. So if you need a shield or some sort of protection from the operator, you're able to make a custom shield for that, or custom tool to protect the operator from a safety standpoint. And also from a quality standpoint, you're able to create tools and trays and jigs and fixtures that allow you to make a higher quality product. So for all those reasons, this is one of the most fastest growing areas in large format 3D printing. Next. And this is a case study by Ford. Everybody knows Ford. It's one of our great customers. That mess on the top of that picture is a welding frame for a prototype. They use about 50 of these welding frames for every prototype car that they make. They may only make 30 cars. And this is a custom-made welding fixture. It takes hours and hours to manufacture to weld 30 welds, 30 different parts, and then they tear it all apart. And they didn't like the labor involved, and they didn't like the waste, because Ford needs to, really wants to be environmentally sound, or environmentally partner in our society, that they didn't like any of that. So they brought on BigRep to find a solution that eliminated that. And the welding fixture below, you see two large format 3D printing welding fixtures that allow them to do what that top fixture does in a fraction of the time, at a fraction of the cost, both in labor and in materials. Not only that, they take these welding fixtures after they're done, and they grind them up and they make additional filament from it. So they try to be as green as possible and save money at the same time. So it's a really great application. We have a full webinar done by Lars Bodner, who is one of the engineers here at Ford in Germany. And if you wanted to, you can see that on our website or on YouTube, and you can get many more applications that that Ford is using the BigRep printer for. I'm just including this one today. Next. So the next case study is a robotic gripper. Robots, as you know, are very flexible. Unfortunately, the gripper is not that flexible. Once you have a gripper, it usually can do just a handful of things. So having the ability to manufacture a gripper in-house gives the owner of the robots a lot more flexibility than he had previously. Previously, he would have to go outside to have a manufactured gripper made, and you just wouldn't do that. Where here, as you see in the bottom right, you're able to make a custom gripper, much more cost effective than going outside, and much quicker. And this particular one has built-in sensors, so you can actually add some intelligence to the gripper to allow the robot to feel and sense it. Thank you. And here's an example of the ABB robot that we have in our facility, using one of these sensor grippers, picking up a part off of the BigRep One and placing it. So it's a really interesting application if you have any robotics to make a custom gripper. It's really interesting. Next. So the next application for large format 3D printing is patterns, castings, and molds. I put the three together, and let's look at a few of those case studies. So the first thing from the patterns, castings, and molds area, it's an area that hasn't seen as much 3D printing as in other applications. So it's really interesting when customers come up to us and say, how can 3D printing help me? And it reminds me of 3D printing a decade or more ago, when not everybody knew the benefits of 3D printing. Sometimes in the molding business or in the casting business, it feels the same. But as 3D printing did in prototyping previously, the pattern business allows them to shorten the lead time, reduce the cost, and reduce both the labor hours and expertise, as you'll see in some of these applications. Next. So the first application is vacuum forming. This is a customer of ours in New York called Boyce Technology. And they were a fixed subtractive company. They have 35 Herco CNC machines. They have a built-in electronic shop, a printed circuit board. Time is of their essence, and they were not convinced they needed additive at all. But one of the applications they implemented once they bought the BigRep printer, and it's quite interesting actually, they didn't buy it for the vacuum forming application. So this is another area where they saw the benefit of using it in other applications inside their factory floor. Now they make all of their patterns with their BigRep printer, and they're able to print it in a day or a weekend as compared to several week lead time if they were to go outside, or many more labor hours if they wanted to use it on their CNC machine or other technologies that they might have in-house. So it's a big benefit for them, and now they make all their tools, as I mentioned, on the BigRep printer. Next. A really interesting case study is here, Tynebridge. They are a propeller manufacturer, as you see here in the pictures, in the UK. And they were posed with several problems. Probably the biggest problem they have is the inability of people to make their patterns. So their pattern became an art form, and their ability to get that type of artist to make these patterns became a real shortage for them. So they were almost forced to go offshore, not because of labor necessarily, but because of their ability to inability to make their patterns. So they brought in the BigRep printer, and you can see their propellers are quite large. They were able to print their patterns in 33% less time, but as you look at the next point, 90% reduction in pattern maker labor. So they, instead of making it in an old artistic way, they were able to make it digitally and really save 90% of the pattern making time to make it more accurately as well. But as I mentioned, probably the biggest benefit is their ability to hire digital engineers to design patterns instead of artists that they can no longer find that capability. So this is really interesting, and sand casting around the world is an area that's really growing in additive. And if you have any of these applications, please come see us, and we'd love to talk to you about how BigRep is saving our customers like Tynebridge a lot of money. The next. And here's a quote from the CEO of Tynebridge. They make very big patterns. 500 by 500 by 750 is not their biggest, but it's their typical. So that's where they thought BigRep was a great solution and a great partner for them. Partner because could make large format printers. They could do these patterns all in one piece, but they could also do it affordable. So BigRep is open material concept, and we'll talk a little bit about that later on when we talk about technology. But when you're making a large format part, one is the ability to make it, And the second is the cost to make it. And with an open source material company like BigRep, you're able to actually make a very cost-effective part. Next. So the next is patterns, and this is a concrete mold that is a case study by Geiger. It's also on our website if you want to read more about this. So Geiger had the challenge of renovating this museum you see in the bottom picture. And one of the things they needed to replace were these concrete arches that were crumbling. And typically, they would make these manually. It would be a very time-consuming process. They would have to replace them often because they would make them out of plywood, and they would get destroyed on each mold that they would pour. So they decided to go additive and to partner with BigRep, and BigRep used its partnership with BASF to create the best material used to make these concrete molds that they can be used more often again. So enough strength to support the concrete, but enough release to allow it to be removed and reused. This particular project created a 50% cost savings from their alternate technology and 45% shorter production time, and really reduced resources all along. Next. And here's a quote from Jörg Petri, who used to work for us, but BASF saw it as such a huge opportunity. They actually asked us if they could hire Jörg, who used to be one of the managers in our Now Innovation Lab, Now Lab. And Jörg was so excited about this concrete form business that he took it from BigRep to BASF and is implementing that with us now from the BASF side. But what he said here, and it's true, in many other applications, that 3D printing allows full control of the design to production process. And in this case, architects, engineers, and manufacturers, you achieve a direct translation of a 3D model to a precise and accurate produced object on site. That's true in so many different applications, as I mentioned before about the Steelcase quote. The flexibility of additive, especially large format additive, goes from prototyping to concrete molds. So it's quite interesting. Next. And now the most exciting future potential, and everybody's been talking about end-use parts for additive. And now you actually start hearing about applications for end-use parts, usage for end-use parts. And I'm going to show you a couple here, but it's really interesting. So as I mentioned earlier, if end-use parts becomes a legitimate solution to be an alternative to molding and casting and forming, and additive as a real alternative, our industry is going to grow rapidly. Manufacturing is going to have a lot more flexibility. So end-use parts, like every other use of additive, allows you to have customization and allows you to deal with small and large batch sizes, allows you to manufacture near the customer. So you can design it to one place, you can manufacture it anywhere around the world. Very interesting. Much less material waste than a lot of manufacturing process. If you think about this part that's sitting on, that's parts printed on our BigRep studio. And if you think about milling that, you're probably milling away 80% of that part. So it's really a waste. So for all those reasons, end-use part is really interesting. I put this quote from PricewaterhouseCoopers in there because it's a very aggressive quote, and we would be really excited if this became a reality. But 42% of manufacturers expect 3D printing to be used for high volume production in the next 3 to 5 years. And I do believe that 42% of manufacturers will be using 3D printers or more for volume, for production. The question is how much high volume, and some of the new technology I'm going to present to you will help that process along, make the traditional versus additive a little easier decision. So wait for that. Next. So back to Boyce Technologies for a second. As I mentioned, Boyce is a multi-million-dollar facility. They actually bought the printer for prototyping, and then they found that these parts were withstanding the criteria they needed for an end-use part. So rather than using them for just prototyping, they ended up using them for real end-use parts. And yeah, Boyce really sells time. And so being able to make their end-use part and not having to design it, prototyping it, go out for tooling, and that's really the cost of time. It's even more than the cost of the tool. But their ability to save time by using additive, and they take on a lot of projects, mostly for the communication industry. You'll see their kiosks and some of their displays all around New York City and all around many major cities, and some of those have BigRep parts in there for real end-use parts. Let's look at one of those applications. So that's me. This was not a setup. We knew they were making these Verizon kiosks. That's a very big part. There's about 10 BigRep parts in this Verizon kiosk. And I just happened to be in New Rochelle, New York, and stopped for lunch, got out of the car. The restaurant we're going to is just to the left of this picture. And I said to the person I was with, "Are you kidding me? That is a Boyce Verizon kiosk. We have to take a picture of that." But it's just interesting to see how Boyce really is using additive in an end-use part application, and really saving them time and money. And it really came to me that there's going to be a race for this end-use part marketplace, and I'm not sure if it's going to be the Fords of the world and the large manufacturers. We have a partnership with Etihad Airways, and they want to print 50% of their cabin interior by the year 2025. That's a really aggressive challenge, and we're up for the partnership and challenge with them. Ford Motor Company and some of their challenges, or it's the Boyce Technology of the world that are already using it for end-use parts today. And there are thousands and thousands of Boyce Technologies wherever you are in the world. You might be one of them, ready to implement additive for real end-use parts. And if you are, and if it's large format thermoplastic extrusion, please give us a call. That's my sales pitch. Next. So it's really a question of now looking at those applications, prototyping, tooling, patterns, castings, molds, end-use parts. What application do you want to redefine? And if you look at the slogan behind me, BigRep, one of our brand messages is to redefine additive, and we hope we can help you redefine additive. Yeah, let us know if any of those applications, or if we can solve an application for you. I don't know who's on the line. It's really interesting, but so I don't know how much you know about BigRep. So I just have a few slides that talks about BigRep Technology, not BigRep as a company. Thank you. Next. As I talked earlier, the BigRep 1 is our flagship. This big orange 500 kilogram of solid industrial manufacturing solution is something that's been out in the marketplace. It's the largest serial production, large format system in the marketplace. Came out in 2014. In 2017, we introduced the Studio. It's our little guy as we talk about it. It is 1 meter by a half a meter by a half a meter. And it fits in a lot of applications and places in the factory. It's quite silent, so it fits in an office environment as well. So a really nice, large format, but really a nice form factor, both in printing area, size, that people can use that don't need the BigRep one. In 2018 Formnext, so November, we introduced a new technology to the marketplace. This was the Pro and the Edge, both enclosed machines, and really taking the thermoplastic extrusion technology to another level, and we'll talk about that in a little bit down the road. And just recently, we introduced the Studio G2, second generation Studio. Takes the Studio that you see in the upper left and really improves on it. Most importantly, we enclosed it, and we enclosed the filament chamber so that we're able to produce with materials that are more industrial based. So everything on that bottom row is able to produce more industrial materials, more functional application materials, more end use part applications. And so that's really where BigRep is moving to that real engineering plastic, thermoplastics. Thermoplastic extrusion is a very efficient way to make real plastic parts. The slogan goes, if you can melt it, we can print it. And that covers so many different materials in the plastic pyramid, and the G2 and the Pro and the Edge are really able to do most of those materials. Next. So on the Pro and the Edge, we introduced a revolutionary new extruder. We coined the metering extruder, or MXT. Today's traditional extruders, ours and everyone else's, even the $500,000 solutions on the marketplace, still are like a hot glue gun that you try to control a drool. That's just it is. And I'm amazed that we are all able to make as accurate of a part as we are when you are trying to control molten plastic. It's very difficult, and it's always a balance between a molten pool and controlling the drool and geometric accuracy and speed. It's really always a balance. The metering extruder actually takes a lot of those limitations out of the extrusion process by separating the thermal process. So we actually drive the filament into a reservoir, and then we use a positive displacement pump, and we actually grab the material voxel by voxel and place it down on the part on the bed when we want it, where we want it, the exact amount we want it. We can start and stop whenever we need to. So there is very little drool at the end of the nozzle that is outside of this pump process. Accordingly, we're able to get a much faster extrusion process, and maybe most importantly, we're able to get a more repeatable process. A lot of the games played in making a good corner or going fast on a long straightaway causes imperfection in the extrusion process, and that causes lack of repeatability in the Z strength. And you can try that by example. If you print 10 dog bones and break them, they will break in a different place on every dog bone because the weak spot is unpredictable. If you did a cross section of a thermoplastic extrusion part today, and then you did an electronic scanning microscope, you would see that there are imperfections throughout that extrusion, and you just don't know where they are. And as we always say in BigRep, especially when it's relevant to end-use parts, repeatability is the most important part of making an additive part and making it for end-use parts. And so the MXT really solves that problem. Next. And as I mentioned, the MXT is on the new Pro and the new Edge. Both were announced at Formnext last year. The Pro we are actually selling right now and starting to deliver. And the Edge is planned for release sometime in 2020. So we announced it because it's very similar technology. The difference is that it's larger and it has a fully enclosed oven chamber, where the Pro is enclosed chamber, a heated environment. Both have the MXT meter extruding technology, and both have a state-of-the-art Bosch CNC control system. One of the few companies, BigRep is, that is actually preparing for the manufacturing process by implementing both MXT and the Bosch CNC controller. We're able to now to make repeatable parts, and the Bosch is able to make sure that those parts that we're creating meet the specification that are designed for that part. We're monitoring so many pieces of information inside the printer, all the speeds, all the temperatures, the driving mechanisms, the thermal process of the extruder. All of those are monitored 500 to 1,000 iterations every second to make sure that we're making a good part. So control with the Bosch CNC controller is critical, and we're one of the only companies that actually have a CNC controller, and we're I think the only company I know of that is using this really high-end Bosch system. So control is one, but data is another. So the ability to store, monitor, maintain the data out of the printer is now possible, and that's with the Bosch CNC controller. The last thing is, because it's Bosch and it's a standard CNC controller, you're not going to be obsolete a few years down the road when you wanted to integrate this or you want to upgrade that. That's one of the benefits of us partnering with Bosch on this. And Bosch actually is a supplier, but they're also a customer of the BigRep Pro. So we're proud to have Bosch on both ends of our relationship. Next. And Andy, that's all I got today, so I'll turn it back to you.
Appreciate it, Frank. While you were doing your presentation, we did have a few questions that came in, and I also would like to remind the audience, if you have questions to ask Frank, now is the time to enter into your chat box. So I'm going to go ahead and ask a couple questions that came in. So Thomas asks, do you have the ability to print with carbon filament?
Yes, probably means short fiber carbon in either nylon or ABS or ASA. So BigRep is open material system, so that's really interesting. That our standard extruder can extrude up to 300 degrees and that allows us to print carbon-filled materials. Actually, Boyce is printing with a carbon-filled nylon. BigRep so provides solutions to the marketplace, and one benefit of buying BigRep material is it's a turnkey solution. You get our material, you get the program that goes with it, you know that they work well together, but we can't be everything to everybody. So we understand that, and we open our machine up and allow you, without voiding any kind of service contract or warranty, to use whatever's out in the marketplace. And we actually partner with a lot of material companies, not just BASF, which is one of our customers and investors, but with other material companies, because we understand that we can't create all the materials in the marketplace. So we have customers using carbon-filled nylon, carbon-filled ABS, glass-filled polypropylene, and we are constantly bringing those into the BigRep family as well, meaning that you have already the programs if you buy them from BigRep, or as we introduce them, you're able to use our program to be close probably to what you might want to use in the marketplace. By being an open material company, we need to compete in price and in quality and availability. So you can ensure that we are a fairly priced material supplier. And if we do offer it, I would recommend looking at us, comparing the materials. You get the program included. I think it's a nice system material philosophy that BigRep has.
Great, thanks, Frank. I had another question that came in from Ramesh, and I will answer this. Will you be sending the slides and audio to all attendees? So we do record these sessions, and we'll be sending out a follow-up email to everyone, and there will be a link to our YouTube channel where you can go back and rewatch this fantastic presentation at your own leisure, and also share it with other people and your colleagues. I have another question that also from Thomas. He is asking, are there plans for an even larger format machine? Because his application, he needs about to print a 6.5 feet sphere, I assume in diameter. So he needs a larger application even.
So Thomas, I didn't mention the size of the edge. It's not 6.5 feet, but it is 1.5 meters in the X, 800 millimeters in the Y, and 600 millimeters in the Z. That is a very large printer. That's designed for specifically industrial, automotive, aerospace applications. We are focused on applications as we create new machines. It makes sense. We didn't create a machine and say what we want to do with it. We went and polled the marketplace and say, okay, what applications do you want to do? Okay, so if you want to do these applications, what materials do you need? We want to make sure our machine then can work on those materials and that geometric accuracy, on that spec, on that, so that we can address that application. So we are not a job shop that can make or want to make a 6-foot printer right now. But I will say that we are BigRep, so it wouldn't shock me that after the edge is introduced and stable in the marketplace, we take on the challenge of even bigger.
Thanks, Frank. I have a couple other questions that are related, so I'm going to combine them into one. A couple of different people asked this. So what type of surface quality are the printer capable of?
Sure. Well, so when you're making large format prints, you have to balance between surface quality, geometric accuracy, and speed. So I always say you want to make as high a resolution part as you need, but not higher. We have an example of a propeller piece, and you can print that in BigRep and in 4 hours. You could print it in 10 hours, and you could print it in 20 hours. And that's the difference between a 2 millimeter nozzle with a 1 millimeter layer height, a 1 millimeter nozzle with a 0.5 millimeter layer height, and a 0.6 millimeter nozzle with a 0.3 millimeter layer height. So our finest nozzle that we think is functional for a large format printer is 0.6 millimeters. So that's our smallest nozzle. With that nozzle, you can go down to 0.1 millimeter layer height. And with that, you can get quite a smooth surface relevant to extrusion and very good geometric accuracy in feature definition.
All right, thank you, Frank. And we have a couple more questions. I know we're running a little long, but if you're willing to stay on, and if the attendees is willing to stay on, we'll stay on as long as you guys need to answer these questions.
Sure.
All right. So another question that came in is, again, there's multiple questions that ask about the same thing, so I'm gonna summarize them. What type of materials are best for each of the application that you discussed?
Yeah, so let's see. That I have to go back through all the applications. So nylon is a very nice broad. We use a PA 6.66. It's a nice material that covers a lot of applications because it has a good strength. It's not brittle, so it has some flexibility, but it has enough rigidity to hold its own integrity. has enough HDT that it can survive out in the market place. So I think, and that's why it's probably the largest used material in injection molding, or one of the largest. So we think that's one of our best materials. But we have a bio ABS material that is BigRep high temp. So a nice thing about that, and that might be something you want to use for the gripper, or something you want to use for some of the concept parts, where it's strong enough. Actually, it's a very strong material. It has enough heat deflection and enough strength, and it's not brittle that much, and it's biodegradable. So you get ABS-like properties, and both in strength and heat, and you can be comfortable that it's not ruining your environment. I think that's quite nice if you can use such materials. And then in the manufacturing tooling, again, I think a good ABS or a nylon is really nice in that environment. You want to be less brittle in such cases if you drop it. So I don't recommend necessarily some of the biomaterials, but a good all-round mid-range engineering material. And again, you often have to balance price and capabilities too. It could be that, for example, from the open market standpoint, not from those that have closed materials, the open market materials are, anywhere with $20 a kilogram to, I don't know, $150 a kilogram. That's an open market material price. So some of our biomaterials are as low as $30 a kilo. Our bio ABS is $50 a kilo, and our nylon is $99 a kilo. So you'll see that sometimes price has to be calculated in there as well. But generally, ABS and nylon cover a big range of the applications.
Great, thanks, Frank. And then Thomas is also asking, and I think we do have these, do we have any example of aircraft wings or flight structures, perhaps a car wing that was printed in the BigRep printing? And I think we do. I've seen
Sure.
them.
Yeah. I would say, call your SarahTech representative, and we can show it to you. If you're in that industry, we can perhaps print a piece for you, find a solution where we get the whole model printed for you. So, yeah.
Absolutely. Yeah, Tom, if we'll follow up with you after the webcast as well. If you in our local area or near one of our labs, we definitely have sample parts that you can check out for sure.
Yeah, so I'd say not all automotive customers are BigRep customers, and not all automotive companies, but so many of them. It's actually the exception that you're not a BigRep customer. And as well, not every aerospace company is a BigRep customer, but many of them. The largest manufacturer in the world in Europe, the aerospace company in Europe, you know who that is, just bought a BigRep Pro. I mean, just as an example. So yeah, we have a lot of experience both in aerospace and in automotive. And as I mentioned, we're a partner of Etihad Airways as well for the operating standpoint, not just in aerospace manufacturing.
Absolutely. And then, we're here at Saratech, and we have, solution consultants that are experts in the industry, and then depends on what application you need, how do you want to use it, what approach you want to use. We are more than happy to work with you to walk through the process and can help you choose the right solution for what you need. All right, I think that's all the questions that we have at the moment. I do want to remind everyone, if you're in one of our local showcase area in Austin or Houston or California, we do have some upcoming 3D printing and additive events that you're more than welcome to attend. Just log on to our website at saratech.com and then click on the events button, and there's pages you can go register. Also, don't forget to follow us on social media, especially our YouTube channel, because we have a lot of tips and tricks, videos, webinars like this published on our YouTube channel. So just go ahead and follow us on social. Click on the little bell icon on YouTube, and you'll be notified anytime a new video or material is uploaded. So with that, I'd like to thank everybody for joining us today. Thank you, Frank, for a fantastic presentation, certainly very informative, and we hope to see you all on a future webcast.
Thank you, guys. Bye-bye.
Thank you.